Hi everyone, this is Mrs. J, and today we are going to learn how to graph sine functions. But first I have a quick warm-up for you guys, so please pause the video. Alright, so even though we haven't graphed these functions yet, we should still know how to describe what will happen to the functions based on the equation. So this is using the same transformation rules we've been using all year. So negative out front is always going to be a reflection over the x-axis. A constant out front will be a vertical stretch or shrink. So this one's a vertical stretch by a factor of 2. A constant next to x will always be a horizontal stretch or shrink. And remember, it's by the reciprocal. So it's actually a shrink by a factor of 1/2. And then if you're adding or subtracting on the outside of your function, it's going to be a vertical translation. And this will go up 6. So we will be graphing sine functions that have all of these types of transformations today. So first we do need to cover some vocabulary. So sine functions and cosine functions and tangent functions are what we would describe as periodic functions. So these are functions that have a pattern that is going to repeat over and over and over again. So a period is the horizontal length of one full cycle of our graph. And that's going to be a really important feature that we're going to look for today. So essentially, how long does it take for your graph to finish a cycle and start a new cycle? A cycle is the shortest repeating portion of your graph. So the shortest portion before it repeats itself. And the amplitude, this word is very specific to sine and cosine. It's the vertical distance between the midline of your graph and the maximum, or the midline and the minimum. So it's middle up or middle down. In other words, it's half the total vertical distance. This will also be a very important feature that will define how our graph looks. So some characteristics of our sine graph. So this is the sine parent function graph. So you can see that it does make this kind of wave shape, and the arrows indicate it's just going to keep traveling left and right and following the same pattern. So that's that periodic function that we're talking about. So for the parent function, if you look at how long one period takes, one cycle, I can see that there's one full cycle from here to here. This is one full cycle, and then after that, it would just start over. So what is that horizontal distance? Well, we can see that it's 2 pi. And it's not a coincidence that a cycle or a period is 2 pi, and that's also a full rotation on a circle. They are related to each other. The amplitude of our parent function, you could see that our midline, the middle of our function, is at 0. The max is at 1. So this distance is our amplitude. The amplitude will also always be positive. So the amplitude is 1. Another thing we're going to look for is going to be our domain and range. For these, our domain is always going to be all real numbers. It's going to keep going left and right. And you can see, though, that our range is restricted. It's bouncing between -1 and +1. It will include those values, so I'm going to use a bracket that's between -1 and 1. And you can see that it does kind of follow this pattern. If you kind of split a period up into 4 parts, just like there's 4 quadrants, I go middle, up, middle, down, middle, up, middle, down. So it just follows a pattern infinitely. So let's talk about our strategy for graphing sine functions. First of all, we're going to be seeing sine functions in this form. So you might see an a value, a b value, or a k value. You may also see a negative out front. So we know that an a value out front is a vertical stretch or shrink in terms of transformations. Now, if you think about what a vertical stretch or shrink would affect, that's actually going to affect your amplitude. So the amplitude of our function is actually going to be whatever a is. If there's a negative out front, that's a different thing. The amplitude's always positive. So whatever a is will be the amplitude. The next thing we're going to need to find, so that's how you find the amplitude. we're also going to need to find the period. So the period is the horizontal length that it takes for our graph to complete one cycle. So there is something that could affect our period, which is this b value, which remember is a horizontal stretch or shrink by a factor of 1 over b, the reciprocal. So there actually is a period formula for these, but really what you're doing is you're taking the original period, which is 2 pi, and you're multiplying it by 1 over b, which is our horizontal stretch or shrink. But if you remember 2 pi over b, that will be your period. And if you don't see a value here, that means our period is simply 2 pi, which would be the period of our parent function. So I'm always going to start by defining those two things. The next thing I like to do is I actually like to sketch in a midline. I'm going to do this with a dashed line. It's not part of our graph, it's not an asymptote, it's just a guideline for me. And that midline will always be dictated by your k value. And we know that the k value represents a vertical translation. So that will shift our graph up or down. So if you don't see a k value, then the midline stays at 0. But if you see that your graph has been shifted up or down, that will shift your midline. Once you have the midline, I like to sketch in the maximum and minimum values. I start at my midline, and then I go the amplitude up and the amplitude down. And then I actually sketch those in as well. So that kind of gives me a boundary where my graph will bounce in between. And it makes it a lot easier to graph them. Then we need, a lot of this is just setup. So another really important thing that we're going to be doing is scaling our x-axis. We're very rarely just going to count by ones. A lot of times our x-axis will have pi. When we're graphing, we are always in radians. So we are going to be rescaling our x-axis all the time. And I do have a trick for this. So if you take whatever your period is and you divide it by 4, we will always use that to scale our x-axis. It's like taking the 4 parts of a circle, the 4 quadrants. So once you've split it up, if all you need to do is follow your pattern. For sine, you start at the midline and you follow the pattern. You go middle, up, middle, down, middle, up, middle, down. So most of the work is setup, and then the last step is finally plotting the points. But we're not actually going to plug in numbers to get coordinates. We're actually just going to follow a pattern that these types of functions have. All right, so let's give one of these a try together. First, I have 3 times the sine of x. So first thing I'm going to look for is the period, which remember is the formula for that is 2 pi divided by b. Well, here I can see that my b value is just 1. So my period is going to be 2 pi, which is the period of our parent function, meaning it's not changed. The amplitude is always the a value. So I can see that my amplitude is 3. So I see that I have no more changes. So my graph has not been shifted up or down. So that means that my midline is at 0. And then the amplitude is the distance from the midline to the max. So from my midline, I'm going to count 1, 2, 3. And this is going to be my maximum y value. And then from my midline, I'm going to count 1, 2, 3 units down. And that's going to be my minimum value. So this will give me a boundary for where my graph will travel. Now I do need to scale my x-axis. So to do that, I'm going to take my period and I'm going to divide it by 4. So if I do 2 pi and I divide it by 4, that means the best way to scale my x-axis is by pi over 2. So that means that this is pi over 2, pi, 3 pi over 2, 2 pi. But really you just need to label 1 so I know what your scale is. I'm going to leave the y-axis alone because I am counting by ones. Okay, so now we're ready to start graphing. Sine will always start at the origin for us, and it will always stick to the midline. So if we're shifted up or down, we're going to start at the midline. So this is my starting point. And then here I have 1, 2, 3, 4 pieces, which will be one cycle. So I follow the pattern. I go up, back to middle, down, back to middle. And I have just drawn one full period of my sine graph. I'm going to see if I can do another period on the left. I'm simply going to follow the pattern but backwards. So I was up, middle, so that means here I should go down, middle, up, middle. So here I have just graphed a second full period of my graph. And again, this only works, we can only do this because we've scaled our x-axis appropriately. Now we could do our domain, which is always going to be all real numbers for sine graphs, and our range we can see is from -3 to 3. All right, let's try another one together. So this graph, I have the sine of 2x. So here I do see a b value. So remember, for my period, the formula is 2 pi divided by b. So if I do 2 pi divided by 2, I can see that our period is pi. So to scale my x-axis, I want to take the period and split it into 4 parts. So I'm going to scale my x-axis by pi over 4. So this would be pi over 4, pi over 2, 3 pi over 4, and then pi. And that's one full period. My amplitude is the number out front, which in this case is a 1. Here, again, I don't have a shift up or down, which means my midline will stay at y equals 0. And I go 1 unit up because my amplitude is 1, which is the distance between the midline and the max, or the midline and the minimum. So from the midline, I go up 1 and down 1. And then I know that sine is going to start in the middle, and it's going to follow the pattern. Up, middle, down, middle. And I can go backwards and just keep following my pattern. So I have graphed 2 full periods of f of x. And you could keep going from there. You don't have to stop at 2 periods. My domain is all real numbers, and this time our range is between -1 and 1. All right, so now we're going to graph a sine graph that has a shift down. So our period is not changed, so it's just going to be 2 pi like the parent function. The amplitude is also not changed, but again, what is changed is my graph has been shifted down 1. So I need to shift my midline down 1. Oh, I'm sorry, I forgot to scale my axis. I can do that really quick. Take your period and divide it by 4. So I'm going to scale it by pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi. Okay, so for my amplitude, I'm going to go start at the midline and go 1 unit up, because that's my amplitude. This is going to be the maximum, and I'm going to go 1 unit down, and that's my minimum. Now I'm ready to graph. I start at the midline, so this time I'm not starting at the origin. You always start at the midline for sine. And now I'm going to follow the same pattern. Up, middle, down, middle. Again, we could just keep continuing that pattern for as long as we want. And there you go. Our domain, all real numbers. This time our range, we can see our low point is -2 and our high point is 0. So we have -2 to 0. All right, now we're going to graph really the last transformation we haven't seen yet, which is this reflection. So I'm still going to start with the same process. My b value is 1, so what that means that my period has not changed. It's just 2 pi. My amplitude, I know I see a negative out front, but the amplitude is always positive. It would just be the a value. So my amplitude is still 1. I'm going to take my period, divide it into 4 pieces to help me scale my graph. Here's my midline. And then I go up 1 to find my max and down 1 to find my min. So sine is still going to start at the midline, but we need to figure out what do we do when we have a negative. Well, a negative out front is a reflection over the y-axis, which will really end up reflecting it over our midline. So if you see a negative out front, instead of going up first, we're simply going to go down first. And then from there, we just continue our pattern. So that's the only thing that you have to change when you have that type of reflection. Again, instead of going up first, we go down first. There you go. And our domain is all real numbers, and our range is -1 to 1. All right, go ahead and pause the video and see if you can try this one on your own. All right, so for this graph, you can see that our change is that our graph has been shifted up 2. So you can see that my midline is now at y equals 2, and I went up 1 and down 1 to get my max and min, and my period is still 2 pi, so I scaled by pi over 2. And then I just follow my pattern, up, middle, down, middle, and I have my domain and range below. Okay, here's one more for you to try on your own, so again, please pause the video. All right, so for this one, we can see that we do have an amplitude change. So the amplitude in this case is 1/2. So you'll notice for this one, you don't have to do this, but I changed the scale on my y-axis. So 2 tick marks is actually 1, as you see I labeled here. So 1 tick mark is 1/2. Makes it a little easier to graph, but you absolutely could just kind of estimate where 1/2 is. So again, the midline is still at 0. I go up 1/2 and down 1/2 to find my max and min. And then I simply follow my pattern. And my range is now -1/2 to 1/2. All right, so now we're going to try working with a couple of changes in one equation. So I see 2 things. I see that reflection, and then I see I am going to have a period change. So let's start by finding the period. So it's 2 pi divided by b. So 2 pi over pi is 2. So this time our period doesn't have pi in it, and that's totally fine. So I'm going to take my period and divide it by 4, so I know how to scale my x-axis. So 1/2, 1, 3/2, and 2. And if I have 4 tick marks, it should be 1 period. My amplitude is 1. Remember, the negative is something else. That is not an amplitude. And then I have my midline at 0. I go up 1, which is my a value, and down 1 to find my max and min. Now remember, the other change I need to watch out for is that negative out front. The negative tells us instead of going up first, we go down first. But then it's just following that same pattern. Again, a really important part of this is that we've scaled our x-axis accordingly. If we were still scaling it as pi over 2 pi, 3 pi over 2, 2 pi, this graph wouldn't be right. So you need to make sure that your x-axis is scaled properly. That's absolutely part of having a correct answer here. And our range is from -1 to 1. All right, let's try another one together. So here I have 2 changes. My period is not changed because my b value is 1, so my period is still 2 pi. But I do see that now I have an amplitude of 2. The other change I see is that I have a vertical shift up 2. So I'm going to draw in the shift first. So my midline is now going to be at y equals 2. And from the midline, I'm now going to go up 2 units to place my maximum, and down 2 units to place the minimum. So this distance here is whatever the A value is, but you need to start with the midline. Our midline has been shifted up, and then from there I go up A and down A. So I'm going to start at the midline because it's a sine graph, but now my midline's up here, and now I just follow my pattern. Up, middle, down, middle. And I'm done. So you'll see that a lot of these graphs end up looking very similar, but what changes is the scale of my x-axis. My range here is 0 to 4. There you go. All right, let's try one more together. I have a lot of changes going on here. So let's start with this period change. Here, I can see that my b value is 1/2. Okay, so if I do 2 pi divided by 1/2, remember that's multiplying by the reciprocal, so it actually equals 4 pi. So my period is 4 pi. So if you take your period and split it into 4 parts, that means we're going to scale by pi. So pi, 2 pi, 3 pi, and 4 pi. My amplitude is 1. Remember, our amplitude is always positive. The negative is something else. And I do see that my midline is shifted down 2. So let's start by drawing in our midline. And then we go A units up, A units down. We start at the midline, but this graph, remember, has a negative out front. So instead of going up first, I simply go down first. So we go down, middle, up, middle, and then follow that same pattern, but in the other direction. And there you go. Domain is all real numbers, and our range is -3 to -1. All right, go ahead and pause the video and give this one a try on your own. All right, go ahead and check your work here. So here, my b value is 1/4. So 2 pi divided by 1/4 is 8 pi, so very long period. So I split that into 4 parts, so I'm scaled by 2 pi. My amplitude is 2, and I'm shifted up 1. So I started with the midline, and then I went 2 units up and 2 units down. Sine will always start at the midline, and here we just go up, middle, down, middle. All right, here's the last example. So one last time, please pause the video. All right, go ahead and check here. We do have a period change. 2 pi divided by pi is 2. So I split that into 4 pieces, which is why I'm scaling by 1/2. My amplitude is 3, not -3. It's 3. And my midline is still at 0 because I did not shift up or down. So from 0, I went up A, down A. I went up 3, down 3. The other thing to check, there is a negative out front. So from the midline, you'll notice I didn't go up first, I went down first. And then check your domain and range here. All right, that is all for today's video. Thank you so much for watching.